Well, hello and welcome back to More Math. It's so good to see you. Woohoo! Well, recently, we've been discussing rates and ratios. So today, we're going to discuss the same thing, but we're going to talk about them in the context of tables. For example, let's have a little story here. I like to drive to Colorado. I live in Missouri, but I used to live in Colorado. I like to go back and go visiting. And recently I thought, I want to find out what my rate is when I'm driving to Colorado. In other words, compare the time to the distance. How far have I gone? So if I've gone 130 miles in 2 hours, okay. So I want to know what my rate is. How fast am I driving? In other words, I want to know how many miles per hour am I going. Do you remember that line means per? So now we're going to say, how many miles per hour? Let's check our chart. For 2 hours, I went 130 miles. Perfect. That is my rate. It's a very special ratio because I have 2 different units, so that makes it a rate. So tell me, what is my unit rate? Do you remember what that means? That means there's a 1 on the bottom. Good job. Ooh, how do I find that? That's right, we divide. Top divided by the bottom. Good job. Top divided by the bottom. All right, 130 divided by 2. Do you have your paper and pencil? Are you working with me? Do it yourself. Pause the video if you need to. All right, good job. Yeah, I was driving 65 miles per hour. All right, good job. So now we have a rate. It's kind of the same thing as a ratio. Let's see how we would write this. Can we plug it in here? What would we put in that box? What would we do? How do we get from 2 to over 130? Right, I multiplied. And what did I multiply by? 65. Good job. That is my rate. So what will we do in this column? The same thing. So wait, 5.5, 5.5, not 55, 5.5 times 65. What is that? You can use your calculator if you need to. Wow, I was driving a long ways. Okay. Last one. I know how far I drove, 682.5 miles, but how long did it take? How many hours? I know that I multiplied to go from the top to the bottom on this table, but what if I do if I'm going from the bottom to the top? I'm going to do the opposite. So what does that mean to do the opposite of multiplying? What is the opposite of multiply? Divide. Good job. So use your calculator. What is 682.5 divided by 65? So, and that's true. That's about how long it takes me to drive to go see my friend at her house there in Colorado. All right, good job. So here you can see I set up a ratio. And its equivalent ratio would be these are all the same. They are equal. They are equivalent ratios. Good job. Let's try another one. A shower uses 12 gallons of water in 3 minutes. That seems reasonable. Okay. So we want to fill in this chart here. What's my ratio? In other words, what's my rate? I know it's a rate because the units are different. All right. I want to know how many gallons per minute. So I'm going to write gallons per minute. Where am I going to do it? Whew, I'm out of space here. Let's see. So how many? 2 minutes. How many gallons? 8. Do you remember what to do now? Oh yeah, same as before. Top divided by the bottom. Good job. So I use 4 gallons of water every minute. That is my rate. That specifically is my unit rate. And again, why is it a unit rate? Because although I have a 4 gallons on the top, there's a 1 on the bottom. It's 1 minute. That 1 on the bottom means it's a unit rate. Good job. All right, let's fill this in. So what did I do to get from the 2 to the 8? I multiplied by 4. Good. Good job. So in the next column, what are we going to do with the 3? Oh, we already know. It's 12. It told us that in the problem. All right. So now we're going to do the same thing that we did before, though. We're going to multiply by 4. How much water did we use? 18. Good job. Uh-oh, it's different again. What do we do this time? Do you remember? We need to do the opposite. Right. So we're not going to multiply. We're going to do the opposite, and we're going to divide. Good job. What's 24 divided by 4? Good job. Now we can take that information and we could fill in a graph. Let's try it. So if there's 2 minutes, it's about 8 gallons. So it's a little less than the 10 here. In that area. 3 minutes. So this time it's a little bit more than the 10. Let's see, 4.5 to 18. So I need to go up. Does that look good? Yeah, I think it's okay. And we got 6 and 24. Let's see, 6 here. Oh, my Sweater got caught. Yeah, that's about right there. Do you see how it makes a pretty straight line? I know it's not perfect. I said about. But really, if we had a great graph, it would be a perfectly straight line. That's pretty straight. Remember, math, not art. Okay. So I see that straight line. What does that mean? The straight line means it's proportional. We're going to discuss that later. How can I use this? Let me show you. What if I took a shower for 10 minutes? I'm just taking my time, take a whole 10 minutes of my shower. How much water would I use? Let's check the graph. And now I'm going to go over. Oh. So if I take a 10-minute shower, I'm using 40 gallons of water. Okay, that makes sense. Because if we multiplied 4 times 10, I would get 40. Hey, that's pretty cool. Good job today. All right, let's do a quick review. A ratio. Now, what is that? Means we're comparing two quantities, two different amounts, two things. So they're two things, but they have the same label, right? The same kind of unit. For example, 12 girls and 13 boys. All right, I know they're different words, but they're both people, so it's the same. But if we look at a rate is always a ratio, but a ratio is not always a rate. Why? Because a rate compares two different things, but it has to have different labels, different units. 65 miles per hour. That's different. So the ratio compares two quantities. They needs to be the same. But a rate compares two quantities, but it must be different labels, different units. Good job. Thanks for joining me. Here at More Math, we really enjoy changing kids' lives one sign at a time. See ya.